It's Missy. All right, so if you're in our basic drawing sort of zone, then you have gone over a couple things already. You've talked about drawing geometric forms. You've talked about the 5 parts of a shadow. Now the next thing to think about is actually shading objects. Now here's the thing. I could show you maps of how you shade each object, and it would mostly work, except it would only work for those particular shapes. So right now what we're gonna go over is something called contours. Everything in the world has contours. Contours are the general shapes of the surfaces of things. You can almost think like, old computer games, whenever they had virtual reality worlds, they would have just general shapes that had big old grids on them and they followed the outside curves of stuff. That's what a contour is. So today we're gonna look at contours specifically of flat-sided shapes. So this is what I want you to write. Contours. Contours are the curves and flats of surfaces. That's what a contour is. So we're going to be using contours to figure out where our shading needs to go. This will be very useful to you in a couple of ways. One, so that you don't have to wonder where you're going to put different values on things. And 2, so you can see the shapes of shadows on very irregular objects, such as faces or chairs. You'll be able to see where those contours are happening because you'll have an idea of how you're going to find them. All right, so I want you to draw a couple of shapes up here. I want you to draw the 3 flat-sided shapes that we know: a cube, a rectangular prism, and a pyramid. Yours don't need to match mine exactly. Feel free to do your own. If you have an easier time drawing it one way than another, then that's just fine. It will not hurt or change anything about what I'm doing up here. You just need to make sure you're following the rules of what I'm showing you, and you'll be fine. So I've got a cube, rectangular prism, and a pyramid. About like so. Now I'm gonna go grab some real life ones to use an example. While I'm doing that, what I need you to do is double check all your parallels. Because remember, you can double check yourself before you wreck yourself on either one of these. If your lines are not parallel and something looks funky, then it's not gonna go really good. And you're gonna really need those parallel lines right now. Especially these corners, make sure that they match these corners. This corner needs to match this corner. You don't want one more pointy and the other more flat. Look through yours and fix it while I grab something. So I've grabbed a few of these to help me demonstrate some stuff. But for now, what I want you to know is that we're going to be drawing the contours of these surfaces. Now I picked these to start with. I picked these to start with because, again, flat sides are a little bit easier to kind of comprehend for y'all. We will do curved ones in a different video, possibly several different videos, depending on how it goes. But all of these are easy enough to do all in one. So what you're gonna do is you're going to make parallel lines on these surfaces. So we're gonna start with the top of our cube over here. It's like we're gonna take this cube, and if this were in 3D space, we'd be drawing basically a grid on here. Now, if you have a hard time drawing parallel lines, like looking at this and going like, okay, I need my next line to be parallel, here's how you're gonna do it the easy way. Go halfway between this point and this point. Halfway, halfway, connect the lines. Do it again. Halfway, halfway, connect the lines. Halfway, halfway, connect the lines. These lines should be parallel to the front and the back of this shape. Whatever line they're connected to, perpendicular in imaginary space, parallel to the ones on either side. We've done it one way, now we need to do it the other. You can do the exact same thing. Halfway, halfway, connect across. Halfway, halfway, connect across. Halfway, halfway, connect across. And you have a grid. Awesome. We're gonna do the exact same thing to this side. What's important to remember is that The number of lines and how evenly they're spaced, etc., doesn't matter. What matters is that those lines are parallel to your edges, at least in flat side shapes. These lines, the direction matters. The spacing, etc., does not. So over here, we're gonna make our grid even smaller. And we're gonna do that by doing the same exact thing as we did before. In half, in half, in half. Actually have a straight line there, that'd be great. We're gonna do the same thing over here, in half, in half, in half. And then we're gonna separate it one more time. In half again. Make that line straight. In half again, in half again, in half again, in half again. And one more time, and one more time, and one more time, and one more time. This grid still has lines going parallel to both the top and bottom edge as well as the right and the left edge. That parallelness is what matters. The number of lines does not. To make this even more complex, and by complex I mean not complex at all, I'm gonna do this other side. Same thing. I'm gonna have my lines that go parallel. But this one I'm gonna do a little different. And this is one that can come in useful to you. If you don't need help measuring halves and halves and halves, and you can pretty much get that parallel line going, then you can do uneven lines. So what if I want one near the top, and I want two near the bottom? If I can get that line to be parallel, it's a funky angle. Two near the bottom. This can be very helpful to you in a drawing if you need to draw something that is equally high as something over here, but it's behind your shape. You can see where those things will be even along the shape. It makes sense. It takes practice. Just trust me. Maybe I want this to have like so. Uneven grid. But as I said, it's not. That was horrible. Y'all need to get after me. It is an uneven grid, but it doesn't matter because it's not the number of lines. It's not the evenness in their spacing. It is entirely their direction that matters. We're gonna go over to the rectangular prism. Same thing. Middle, middle, divide. Middle, middle, divide. Middle, middle, divide. Divide. Over here, even smaller. Divided a lot, divided a lot. Doesn't matter. We have lines parallel to this side of the side and this side of the side. Over here, over here, over here, and all these verticals. That matters. Over here, if you have a particularly small shape, you might only draw one on each side, but that still gives you the directional lines you need. Because what I want you to notice, we're gonna use this one as our example. Our top grid over here has lines going along one diagonal and the other diagonal. Our left side has one of those diagonals, same as the top, but the other lines are going vertically. So it's different lines being used, vertical and one horizontal. This one, two horizontals. And our right is different again. We have the opposite horizontal to left, and again, a vertical. So two diagonals, one diagonal vertical, other diagonal vertical. What that means is that from a standpoint of the metaverse and God, each of these will be shaded a different shade of gray. And ostensibly, if I had more cubes in the same picture, anything that had those same lines, say I had another cube that had the same diagonals across the top because they're both standing upright, they would both be the same shade of gray. The lines that had, like so on this side, if they had another one that matched, same shade of gray. All of those can match. Over here, same difference. All of these have different directions. We've got a diagonal and a horizontal for the top, which is different than the vertical and the horizontal of the front, which is different than the vertical and the horizontal from the side. Because those are all different, they will be different values. Now, over here, the contour for the pyramid is not particularly different along the top. It's still basically just a square. So it's going to go the exact same way that everything else has. But the contour for this is a little different in one way. And that is when we're looking at the triangle side. Now, you could say that this triangle is fitting inside a cube. You could be like, yeah, there's a cube here. It looks like this. But this side tilts inwards, and therefore it does not follow this cube. So we have to be a little bit different about the sides. Luckily, it's not very difficult. So we have one side that we can very easily find along our edge. Right there. Now, if I were to take this in 3D space and I were to draw a bunch of lines like so, they're all parallel to one another. This is the part that gets a little tricky for kids. We're still drawing parallel lines right here. But what kids end up wanting to do is they start drawing these as like a fan, like this. I don't know why they do that. It's just some kind of trick of the brain, but that's not what you want. You want to draw them as parallel as they normally would be. Almost as though you were drawing them off the edge and continuing them in the empty space next to your triangle, like so. That's our first direction. The second direction on here changes a tiny smidge. For the sake of ease, I'm going to put my starting points at the same places as these contour lines intersect with my edge. But now, because I can't go straight down, again, we're not talking about a cube where one of my parallels is here. Instead, we have two lines that are not parallel. The two edges of my triangle here are not parallel. So our lines here will also not be parallel. They are all going to the same top of the cone. And if I hadn't covered this one in complete gobbledygook of parallel lines as well, it would also be having lines that go parallel and to the point. But again, those are different grids. This grid looks different than this grid, looks different than this grid. And because they're all different grids, all of those lines are different from one another, we will have different shades of gray. So what I want you to do, draw yourself a little star. I want you to write these words. Sides with different directions, meaning the directions of these lines, will be shaded different values. And just in case you've forgotten, values means shades of gray. Again, gray could be blue or purple or whatever. It's just all of the lights and darks. Lights and darks. All right. So that is using contours to help you figure out what parts of shapes are going to be different values. Again, this is the simpler flat-sided shapes. We'll talk about curved-sided shapes another day. Yeah, so that's everything. Bye.